All right, here we go. Unit 3, Lesson 3. Graphing systems of linear inequalities. So let's see here. We're going to stay with graphing. Again, just like how we got done graphing systems of equations, we can also graph inequalities. Remember, the big difference with that is that your solutions are a range of numbers, so you have to have shading. You have to shade where the correct answer is. So let's do an example. Let's say that our first equation is y is greater than negative 2x minus 5. I'm going to use blue for that one. And then our second one is going to be y is less than or equal to x plus 3. I'm going to scroll down, get my graph paper. That's not it. There we go. So again, what you guys have to remember is you got to have an x and a y axis. Again, I keep telling people on their assignments they have to do that, and you have to have a label. So I'm going to label it at 1, 2, 3, 4. And right here. So I'm going to graph the red one first just because I already have my red color out. So again, y is less than or equal to x plus 3. Start at positive 3. And I can go up 1 and over 1, or I can go down 1 to the left 1, down 1 to the left 1. My line is going to look something like this. Now, because it's or equal to, that means I use a solid line. So I'm going to use a solid line like this. And then I like to try the point 0, 0. Again, that's my favorite point to try because it's super easy. 0 plus 3. Yes, it's true that 0 is less than or equal to 3. So we're going to shade the side that has 0, 0. So I'll use red to shade it. So again, anything that's over here could be a potential solution. And our second equation, where you're going to use blue, y is greater than negative 2x minus 5. So I start at negative 5. Go up 2 over 1, up 2 over 1, up 2 over 1. Okay, and then again, I can connect it. I can choose 0, 0 again because my line does not go through it. However, I made a slight mistake. I need to use a dashed or a dotted line because it does not have or equal to. So again, if you don't have an or equal to sign, you have to use a dashed or a dotted line. I use them interchangeably. They're the same thing to me, dashed and dotted. And I'm going to choose the point 0, 0 again and plug it in and see if I get a true statement. 0 less than negative 2 times 0 minus 5. 0 is or greater than 0 minus 5. That is a true statement. 0 is greater than negative 5. So we're going to shade the side of our line that includes 0, 0, which is all of this right here. And you'll notice that there's a section of this that overlaps. That's our solution. So the two shaded areas, I'll shade it, oh goodness, I'll shade it in green. Those two areas is our solution. So anything in between these two lines is going to be our solution. Again, you need to have one solid line and one dashed line. Let's do another example. Say we get equations. Again, the equation is 2x plus 3y is less than 6. That's equation 1. Equation 2 is y is greater than or equal to negative 2/3 x plus 4. When you graph it, okay, I'm just going to kind of eyeball it, but you'll get a line that looks like this, and it'll be shaded up here. and then you'll get a dashed line down here, but it'll be shaded down here. Notice none of these two shaded sections don't intersect. So again, if they don't ever cross each other, if they don't intersect, then that means you have no solution. Okay, so this would be an example where we have no solution because my two shaded regions do not intersect each other. All right, and then we can also use inequalities. So again, y is less than or equal to 3, and then let's say y is greater than absolute value of x plus 4. Did I say inequalities? I meant absolute value. So if I graph my first equation is really easy to graph. Because it's just y is less than or equal to 3. So I draw a horizontal line on 3, and then it would be shaded everything below. So everything below my graph would be shaded because it's less than. And then when I graph the absolute value, again, I see, okay, I have my parent function is the absolute value, but it's adding 4. Again, it's opposite, so that means I need to move to the left 4. So 1, 2, 3, here's my fourth, and then I draw my absolute value function. I almost made the same mistake again. I need to use a dotted line. Because I do not have or equal to. Again, Mr. Larson's favorite point is to choose 0, 0. So if I choose 0 is greater than 0 plus 4, we see that 0 is not greater than 4. That is false. So I cannot shade the area that has 0, 0. I must shade the area inside of my absolute value. Okay, so that would be all of this stuff. And then you'll see there's a slight area that is combined that intersects both. I'm going to shade that green. So this green area underneath my line y is less than or equal to 3 in between my v-shaped absolute value is my solution. So this green area right here is my solution. I guess we have one more example. It's kind of like a multi-step problem. So a discount shoe store is having a sale. You can save 10% to 60% on all footwear, regular price between $20 and $80. So we're gonna write an equation that represents this. So again, my x values, if x is my price, it's got to be larger than 20. So x is greater than or equal to 20, but x is also less than or equal to 80 to represent $20 to $80. And then my sale price is at least, if I think about it, if it's 10 to 60% off, if I start at 100% and I take away 60%, that means it could be 40% on, or it could be minus 90% or minus 10% would just be 90%. So my price is going to be either 0.4x or 0.9x. So I'll draw that up here. Again, y is greater than or equal to 0.4x, and then y is less than or equal to 0.9x, depending on what percentage the sale price is. So if I were to look at like a graph, again, I'm going to have bounds. So if here's just my regular XY axis, let's count 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then I'm going to count by 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Starting with these ones right here, again, x is greater than or equal to 20. So that's going to be a vertical line. It's going to be solid right here. And x is less than or equal to 80. So I know, again, because this sale only works for items that are priced in between $28 and $80, my answer is going to be in between there. Looking at my y-intercepts, I can see that, let's see here, y is greater than or equal to 0.4x. So again, starting right here, I would have my 0.4x would be flatter than my x, than my 0.9x. So it'd be something like this. And then graphing 0.9x would be a little bit steeper. And then I could, again, think about it as anything in between these bounds could be my potential sale price. Again, I can't go above it. I can't go outside the X bounds as well. I did just kind of eyeball those graphs. Again, you could use Desmos to get a more accurate answer. But that's just an example.